Welcome to this explainer, everyone. Today we are playing a high-stakes game. Think of your Cambridge computer science exams as a high-stakes casino table. You need to know exactly when to hold, when to fold, and when to go all in on your answers. Now, if you're studying for your IGCSE or O-level computer science exams, whether that's syllabus 0478, 2210, or even looking ahead to AS level 9618, you probably already know the basic rules of binary math. You know that 1 plus 1 equals 10 in binary. That is the bare minimum. But here is the secret that separates the top-tier students from the rest. Examiners aren't just testing your math. They are testing your ability to apply that math to real-world computer science structures. Today, we're going to look at a highly effective exam strategy cycle that will ensure you don't just recognize the concepts, but can completely master the examiner's game and win those top marks. I've structured our analysis today into 6 key areas to give you a complete, foolproof, strategic masterclass. We'll cover the real-world binary problem, concept compression, the context trap, the rapid method review, our 4-prompt memory tool, and finally, your final exam checklist. Okay, let's jump right in. Section 1, the real-world binary problem. We are kicking things off by pulling binary addition completely out of the textbook and directly into the digital scenarios examiners actually use to test you. So, look at this question on the screen. Why do students who know the binary math perfectly still lose marks in the exam? Imagine a student, let's call him Alex. Alex is brilliant at math. He goes into the exam, sees a question about binary overflow, and immediately overloads the paper with every single raw computer science fact he knows about binary addition. He writes a massive paragraph. But when the results come out, the examiner has practically covered his answer in red ink. 0 marks. Why? Because Alex treated the math as an isolated fact rather than a connected process with a practical consequence. He didn't analyze, he just dumped facts. In Cambridge exams, you do not reach the highest marks by just showing you can add ones and zeros. The exam demands precise terminology. It demands that you decode the command words, explain processes clearly, and connect them directly back to the specific problem given in the prompt. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. To get those highest marks, you need to recognize that binary overflow matters differently depending on the exact context of the system. Let's look at these real-world transfer scenarios. Take a retail checkout system versus an automated industrial robotic arm. The exact same binary overflow error has vastly different consequences across these two systems. If an 8-bit register in a retail system overflows, maybe a price calculation loops back to 0, and a customer gets a free pair of shoes. It's bad for business, sure. But if an overflow happens in an industrial robotics control system, you could literally have heavy physical machinery crashing through a factory floor. Showing these logical links to the examiner proves that you understand not just the name of the concept, but the very real reason for using it and the real-world consequences when data exceeds a system's physical limits. Moving right along to Section 2, Concept Compression. This is all about distinguishing nearby concepts so you never get tricked by a cleverly worded question. The crucial point here is that when we define overflow, we must immediately link it to the data, the device, or the practical consequence involved. You can't just recite a memorized one-line label. A lot of students will just write, an overflow is when you have an extra bit. That is not enough for top marks. It is an error, where a calculated value physically cannot fit into the allocated storage space. Imagine a tiny 8-bit register in a CPU suddenly trying to hold a 9-bit answer. It physically drops the most significant bit. By answering exactly what problem it solves, what specific hardware device is involved, and what practical consequence follows, your terminology becomes deeply meaningful. You're showing the examiner that you truly understand the architecture of the computer, not just a mathematical trick. Your revision notes absolutely must train you to compare concepts side by side. Why? Because examiners love, and I mean love, to test if you confuse arithmetic processing with logic processing or memory with storage. Computer science mistakes frequently arise right here in the confusion between nearby concepts. You might know everything about binary addition, which is arithmetic processing. But if an exam question asks about logic processing, like and, or, and not gates, and you start talking about binary addition, you'll answer the question entirely wrong. Similarly, if you say the overflow impacts the hard drive storage instead of the short-term RAM memory or CPU registers, you will drop crucial points. You have to be precise. Good notes train you to spot these differences instantly, so you never fall for the examiner's traps. Which brings us perfectly to Section 3, the context trap. Let's look at the absolute villain of our story, where a perfectly good theory goes completely to waste. Let me introduce you to another student, Sam. Sam is the opposite of Alex. Sam understands the real-world stuff, but he rushes. He completely misses the command word requirements in the question. He uses vague, generic wording. This slide lists the most common errors examiners see every single year, and they are exactly what Sam does. If the exam asks about a security incident or a school network, you will lose marks if you just name a method without explaining how it works inside that specific school environment. Sam falls into the context trap. He fails to anchor his explanations to the specific scenario provided. If the exam context is an embedded system in a microwave, your answer must stay inside that microwave. Students constantly lose marks by giving an advantage with no reason, by skipping vital steps in a sequence, or by describing a technology that merely sounds related but doesn't actually fit the scenario. You have to play the game, decode the command words, and anchor your knowledge. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Section 4, Rapid Method Review. This is the disciplined path. To guarantee those top marks, we are going to implement a technical methodology to carve a precise path through any exam question. Think of this as the computer science version of the PL framework: point, evidence, explanation, link. Following these 4 steps ensures you correctly diagnose the demand of the question. It stops you from just writing down everything you know without any direction. Step 1. Identify. What exactly is the task testing? Is the command word asking you to describe binary manipulation, or is it asking you to evaluate a method? Step 2. Classify. Is this a hardware issue, a software issue, or a data issue? Step 3. Explain. Write out the sequence of the process so clearly that another learner could follow it step by step. And finally, Step 4. Connect. Link it right back to the context. Are they asking for causes, effects, advantages, or disadvantages? When you apply this rapid method review to your answers, your mark potential goes from 0 to 100% almost instantly. Section 5. The 4-prompt memory tool. This is where we build those exam-ready answers. I want you to treat this next part like an interactive workshop. Imagine a 60-second timer counting down on your screen right now. If I asked you to speed write a perfect paragraph on binary overflow, could you do it? This framework provides a highly reliable structure you can use to test your own readiness before stepping into the exam hall. If you can confidently answer these 4 prompts aloud for binary addition, your knowledge is locked in. What is it? Forces you to secure the exact definition. How does it work? Makes you rehearse the process step by step. Where is it used? Forces you to think of real-world systems, avoiding the context trap. And why is it better or worse? Gets you ready for those tricky high-mark evaluation questions. If you are ever studying and you find the flaw, meaning you struggle to answer one of these 4 prompts aloud, that is your immediate signal to stop, go back, and rebuild the topic from a worked example. Finally, Section 6, your final exam checklist. Let's wrap up with the ultimate layered strategy to ensure you are fully adaptable in those final days before the exam. This 3-pass cycle is an absolute game changer. It's incredibly effective in computer science because Cambridge exams constantly mix pure theory with applied scenario-based reasoning. Your first pass through your notes is purely about definitions, making sure you don't confuse those nearby concepts we talked about. Your second pass is where you practice the math. You literally draw out the registers, and you visually show that overflow bit dropping off the end. But the third pass, that is the magic one. That is where you actively change the scenario. You ask yourself, how would this overflow impact an e-commerce website versus a hospital's life support system? Managing your time through this matrix style of revision builds absolute exam resilience. You'll be ready for anything they throw at you. I am going to leave you with this exact exam-style question. Test yourself using our 4-prompt tool and see just how prepared you really are. Think of a scenario right now. Maybe it's an odometer rolling over in a digital car dashboard. Can you explain the arithmetic processing taking place, identify the physical limitation of the memory register, and explain the real-world consequence to the driver when that system overflows? If you can build that narrative, you aren't just memorizing facts anymore. You are thinking like a true computer scientist, and that is exactly what the examiners want to see. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only as they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at aceexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to Ace the Exams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.